The second part of Mod 9a, we are going to be solving exponential equations. The first kind of exponential equation that we're going to look at, you are going to solve by finding a common base. Our first example is 2 to the 6x equals 8 to the 3x plus 4. Look at the bases. We have a base of 2 and a base of 8. 2 is a prime number, so you can't do anything with that. But can you write 8 as a power of 2? You can. So the left side, we're going to leave alone as 2 to the 6x. The right side, we're going to take out 8 and replace it with 2 to the third. And then we're still raising that to the 3x plus 4 power. The left side stays as is. On the right side, we have 2 to the third being raised to another power, and exponent rules tell us to multiply those powers. So the right side becomes 2 to the 9x plus 12. Once you have both sides written with the same base, in order for 2 to the 6x power to be equal to 2 to the 9x plus 12 power, the exponents would have to be equal to each other. So we drop the bases and just set the exponents equal. 6x equals 9x plus 12, and solve this equation. Subtract 9x on both sides. You'll get negative 3x equals 12. Divide both sides by negative 3, you get x equals negative 4. On this problem, we have 81 equals 27 raised to the x minus 2 power. Neither 81 or 27 are prime numbers. But if you think about it, they are both powers of 3. So we're going to start out by rewriting 81 and 27 as powers of 3. 81 is 3 to the 4th. 27, I'm going to replace with 3 to the 3rd. But that 27 is being raised to the x minus 2 power, so I have to keep that. On the right side, we have a power raised to a power. So we're going to leave the left alone, and we're going to multiply the powers on the right side. So it becomes 3 to the 3x minus 6 when we distribute our 3. Now, in order for 3 to the 4th to be equal to 3 to the 3x minus 6, the powers have to be equal to each other. So we drop the bases and just set the powers equal to each other. And now solve this for x. We're going to add 6 on both sides, and we get 3x equals 10. Divide by 3, we get x equals 10 thirds. We are going to now be looking at exponential equations that cannot be written using the same base. When this happens, there are some steps that you should always follow. You take either the common log or the natural log. It does not matter which one you use of both sides of your equation. When you do this, you use your log properties and drop any exponents to the front. We do this because our variables in an exponential equation are in the exponent, and we need to get them down out of the exponent in order to solve for them. If you have any distribution that occurs, you need to do that. Then you're going to rewrite your equation so that any terms that have the variable are on one side and non-variable terms are on the other side. Factor out an x from all the terms on the variable side if you need to. Divide both sides by the term or the quantity that's with the variable. And then depending on the instructions, if you are being asked to find an actual solution, you're going to put all this in your calculator. Make sure you watch how you are being asked to round. The first of these problems that we're going to do, we're going to solve for the variable and write exact answers. That means we are not going to put it into our calculator. You may use either base 10 or base E logarithms, common log or natural logarithms. Our first example is 15 to the x minus 7 equals 4 to the negative 7x. I'm going to do this problem using a common log, but either one is fine. So we start out by taking the logarithm of both sides. That means just put the logarithm out front on both sides of these. Well, now, because we have logarithms, we have the rule of logarithms that says we drop the power to the front. So the left side becomes the quantity of x minus 7 times the log of 15 equals the right side becomes negative 7x times the log of 4. On the left side, we do have distribution that needs to happen. We need to take the log of 15 times both of those terms. So we will have x times log of 15 minus 7 times log of 15 equals negative 7x log of 4. The next thing that we need to do is get all the terms that have x's on one side and all the terms that don't have x's on the other side. I'm choosing to have my x's on the left, so I'm going to add my 7x log of 4 on both sides. That means that I also need to add 7 log of 15 to both sides and get that term on the other side. The left side now becomes x log of 15 plus 7x log of 4 equals 7 log of 15. Once you have all your x terms on one side and the non-x terms on the other side, you factor out an x on the variable side. If I pull the x out of the first term, what would be left would be log of 15. If I pull the x out of the second term, what would be left would be the 7 and log of 4. And that all equals 7 log of 15. My whole goal is to solve this for x. Right now, I have x times that quantity on the left. So in order to get the x by itself, we're going to divide both sides by that quantity. That gives me x equals 7 log of 15 over log of 15 plus 7 log of 4. This is my exact answer, which is what the directions ask for. Do not put this into your calculator. We have the same directions for this problem where we are going to write exact answers. This time I'm going to use a natural log instead of the common log. Taking natural log of both sides gives me the natural log of 5 to the 4x equals the natural log of 7 to the x plus 3 power. Now, because we have logarithms, we can drop the exponents to the front. So we have 4x, the natural log of 5, equals the quantity of x plus 3 times the natural log of 7. Anytime you have a quantity as your power, you're going to have to distribute on your next step. Left side stays the 4x natural log of 5 equals, distributing on the right side will give me x times the natural log of 7 plus 3 times the natural log of 7. Now we need to get our variable terms on one side. I'm going to subtract x natural log of 7 on both sides, giving my left side as 4x natural log of 5 minus x natural log of 7 equals 3 natural log of 7. Factor out an x on the left side, so you will have x times 4 natural log of 5 minus natural log of 7 equals 3 natural log of 7. To get the variable by itself, we're going to divide by the quantity. We get x equals 3 natural log of 7 divided by the quantity of 4 natural log of 5 minus natural log of 7. This is the exact answer, so we stop there. On these problems, we are still solving for our variable, but we will be getting numerical answers this time, so we will be using our calculators. When the instructions say do not round intermediate computations, that means once you have a logarithm in your problem, don't put it in your calculator until the very end. We are going to round our answers to the hundredth, so that means to 2 decimal places. Our first problem, we have 9 to the negative 2x power equals 4. I'm going to use a common log just to show you that it can be done either way. So we're going to start out by taking the common log of both sides. We'll have log of 9 to the negative 2x equals the log of 4. Because we have a power on a logarithm, we're going to drop that to the front and have negative 2x times the log of 9 equals the log of 4. We only have one variable. It's on the left side, and right now it's being multiplied by a negative 2 and a log of 9. So to get that variable by itself, we're going to divide both sides by what we need to get rid of, the negative 2 and the log of 9. So our x equals the log of 4 over negative 2 times the log of 9. This is the exact answer. To get the rounded answer, you're going to put that into your calculator. When you put it in your calculator, you're going to put this in as log of 4 divided by, open a parentheses, negative 2 times log of 9, and then close your parentheses. Your answer should come out rounded to 2 decimal places as negative 0.32. Another problem where we are going to round to 2 decimal places, and this time I'm going to use the natural log. So if we take the natural log of both sides, we will have the natural log of 11 to the y plus 2 power equals the natural log of 15. Drop your power to the front, so we will have y plus 2 quantity times the natural log of 11 equals the natural log of 15. Distribute your natural log of 11 times that quantity, so we will have y times the natural log of 11 plus 2 times the natural log of 11 equals the natural log of 15. The only term that has a variable is the y natural log of 11, so we need to get it by itself, and we're going to do that by subtracting 2 natural log of 11 on both sides. This makes our equation y natural log of 11 equals natural log of 15 minus 2 natural log of 11. To get the y by itself, we're going to divide both sides by natural log of 11, which gives us an equation of y equals natural log of 15 minus 2 natural log of 11 over natural log of 11. This is the exact answer. In order to put this into your calculator, you need to put it in as parentheses natural log of 15 minus 2 natural log of 11, close your parentheses, then hit divided by natural log of 11. Your 2 decimal place rounded answer should be negative 0.87. These problems have the same instructions of solving for the variable and not rounding intermediate computations, and also rounding to the hundredth. Before we begin these, I want to remind you that we have a logarithm property that says that if you have the log base a of the argument a, if your base and your argument are the same, the answer equals 1. What's different about these problems is that you will have an e in them as one of your numbers. If you have e in the problem, you automatically want to use a natural log because natural log is a base of e, and it will allow us to use the logarithm property that I just reminded you about. We're going to start out then by doing the natural log of both sides. Once we've done the logarithm of both sides, we want to drop the power on the logarithm to the front. So the left side will become the quantity of x plus 2 times the natural log of e equals the natural log of 5. But if you think about it, we now have a logarithm of base e with an argument of e. So I know that that natural log of e equals 1. So I really just have x plus 2 times 1. That just simplifies to be x plus 2 equals the natural log of 5. How do I solve that for the variable? I subtract 2 on both sides. So my variable x equals the natural log of 5 minus 2. Put that into your calculator and you should get a 2 decimal approximation of negative 0.39. Because we have e to the negative 2y equals 7, as soon as I see that e, I know that I need to do the natural log of both sides. So I have natural log of e to the negative 2y equals the natural log of 7. Since I have a logarithm, I'm going to drop the power to the front, and it becomes negative 2y times the natural log of e equals the natural log of 7. In our last example, we just talked about that the natural log of e equals 1. So our equation becomes negative 2y equals the natural log of 7. I need to solve that for the variable y, so I'm going to divide both sides by negative 2. We now have y equals the natural log of 7 divided by negative 2. Put that into your calculator. You get a 2 decimal approximation of negative 0.97.